Good morning, everyone. I am Dr. Janish Patel. I'll be talking about understanding the atomic clocks. So, we'll see what is the science behind the working of these atomic clocks and how it is impacting our universal coordinated time. So, to begin with, the importance of the accurate time. So, we know we are all busy in our day-to-day life, whether it is our day-to-day activity, or scientific research, or we are making global communication. One common factor which affects all of us is the time. What is the precise timekeeping is very crucial for all of us. So it is very essential for all of us to ensure the synchronization in the technology in our communication that we are using in our day-to-day lives. If we see the historical methods, how the ancient people used to measure the time. So they used to use the natural elements such as moon, sun, what are the cycles of the moons and suns. So based on that, they would measure the time. And as the development progressed, there were mechanical clocks were developed in the 14th of century with more accuracy, more precision through various technologies over a period of centuries. And further time progressed, and there was a time when the people found a very uh, precise measurement domain, the atomic time. So the shift happened in mid 20th century, and to be very precise, it was in 1955 the atomic clocks were begun to develop, and this transition changed significantly in determining the time in terms of its accuracy, in terms of its definition and the understanding. So let us look at the basics of the atomic clocks. So the atomic clocks are basically very accurate devices. They are used based on their natural frequency of the atoms, the natural frequency of the atoms. So typically cesium and rubidium, these are the quite common atom which are generally used to measure the time, and they have become the standard for defining a second, right? So for example, this cesium atom, if we take an example of cesium atom, so this cesium atom, so the frequency of the electron which is there in the cesium atom, so we know the atoms have the nucleus in their center and the electrons which are revolving around the nucleus. So these cesium atoms clocks, so they are calibrated to the vibration of this cesium atom, which is oscillating at about 9,192,631,770 times per second. So you can imagine how fast these atoms are moving. In 1 second, it is making this many oscillations. So if this is the case, then this would improve our accuracy in terms of millions of digits. So what are the components of this atomic clock? So atomic clock comprises several key components, such as you have an oscillator which would generally create the oscillations. You have a microwave cavity which would actually generate the microwaves. You have an atomic source which would generally create this atom, which in our case we discuss cesium atoms, or let's say rubidium atoms, and the detection system. So when these cesium atoms, they are passed through the uh, microwave cavity, so these microwaves would actually create a tweak in the oscillation of these cesium atoms, and there would be a resonance when the frequency of these atoms and the frequency of the microwave, they would match. That would be detected in our systems. So through this detection system, we would actually make measurements of the times. So these components work together to excite the atoms and to create the vibrations, and these vibrations are actually measured accurately. And if you compare it with mechanical clocks, so such as in mechanical clocks, generally we use gears and springs. These are the basic components. But atomic clock utilizes these atomic oscillations, as we have mentioned. This fundamental difference would actually lead this atomic clock to create an unparalleled precision. It is an unparalleled precision. No other clock would actually create measurement of time with such an accuracy. And uh, if we look at this cesium atom specifically, then this cesium atom is highly reactive. It is very soft. It is a gold colored metal with an atomic number of 55, and it has this unique property that it oscillates at a consistent frequency when you expose these atoms to microwave radiation. So making this is a very perfect candidate for timekeeping to make our time measurement precise. So this frequency of oscillation of the cesium atom is approximately 9,192,631,770 cycles per second. So this frequency is our fundamental base that we are using, and that is the definition of the second as per the International System of Units, which solidifies its importance in the time measurement. And this use of cesium atom in the atomic clocks allows us for the unparalleled accuracy for the time measurement. And uh, it is very, very, wonderful to see that this precision is about 1 second over millions of years. So that is a very, very great accuracy, and this is very crucial, as we are relying in our day-to-day life on GPS and certain telecommunications or even in scientific research. So this accuracy is very, very critical. And let us see how it impacts our universal coordinate time. So what is this universal coordinate time? So universal coordinated time is the baseline time, that is the standard used worldwide, and it is derived from the International Atomic Time. And this International Atomic Time is actually used to create a synchronization with the rotation of the Earth through the leap seconds to create an accuracy over a period of time. So what does it mean? If there are some deviations in the rotation of the Earth, then we would have to make our adjustment in our atomic clocks, because ultimately this movement of the atomic movement of the rotations, deviation from the rotation of the Earth would actually impact the frequency of our atomic clock. So we have to adjust our atomic clock in that way. And how this atomic clock contribute to this UTC? So as we have already mentioned that it has an accuracy which is how much? It is about 9,132,770 cycles per second. So it is almost millions of years, over 1 second over millions of years. So these are the perfect cornerstones of our UTC. And the International Bureau of Weights and Measures, they utilize this data from over 300 atomic clocks worldwide to continually update and refine the UTC. So as we have just mentioned, these rubidium and the cesium atomic clocks, there are about 300 such atomic clocks all over the world. So this BIPM would actually utilize the data from all these atomic clocks, and they would ensure that the time remains consistent and reliable. So this is all about the time measurement, how the time uh, is actually measured in our day-to-day world, and how we are all synchronized with a universal time. So I hope you have enjoyed this session. Thank you for your attention. Thank you very much.